Now, through each step, the SQL engine is considering, it doesn't actually necessarily pull out the full result set, but it's got an estimated or theoretical result set. So like when it goes to the from clause, we'll jump down to our actual statement, then the theoretical result set is, at that point, the entire table that's listed in the from clause. I'm sorry, okay, there we go. So here we have a normal query. We're in AdventureWorks today, and we're pulling some information on product category and color, and then some aggregate data. And down here we've rewritten this exact same query in the order that the SQL engine looks at it. So let's go ahead and go through it real quick. The SQL engine first looks at the from table, the from clause, and it says, okay, you know, the biggest possible result set at this point is the entire table. Next, it looks at any joins, the on clause, to see how it's going to join that to whatever's in our join clause. At this point right here, the estimated result set can get no bigger than what's in our from and our join table. Everything from this point forward is whittling that row set down to the eventual row set that we actually want to get back. And it starts off immediately whittling it down with the where clause. In this case, we want where the subcategory ID is not null and where color equals black. Now that we've got our row set limited down to just a certain number of rows, limited by our where, we can group that as we like, in this case by category and color. And we're only really interested today in things that have an average standard cost of about 100. So it applies the group by and then applies the having. Interesting little trivia. You can have a having clause in your select statement without a group by, but it just behaves like another where clause. So if you're ever in SQL Bowl at pass, then now you know one of the good answers. Okay, so now we've got our result set, we've whittled it down, we've grouped it, we've limited those groups. Finally, we arrive at our select statement and say, okay, what actual columns do I want back from this estimated result set? And at that point, the SQL engine pulls columns and does the aggregates on them. Now, only after that, and we've skipped a couple of things, 5, 7, 8, 9, 10, we're missing in this particular select or a top, but that's okay. Only at that point do we do our order by, once we have our finalized result set. And an answer to a long-standing question is, why can't you use column aliases anywhere else in your select statement? It makes sense to us if you come up here to the normal query and say, okay, my column aliases are right up here at the top. Why can't I use those in my having clause? Let's go ahead and run this and see how it fails, because we have, doggone it, I originally had the average cost alias right there. So why does that fail when I've got my column alias here? Well, it makes sense to us that it should work, but the SQL engine doesn't read it that way. It reads it in this order. So that the only point at which it realizes that there are column level aliases is in the order by clause. That's why you can use it there. So that's our quick hit on logical order. If you'd like to know a little bit more about that, I highly recommend Itzik Ben-Gan's books, the T-SQL Fundamentals and T-SQL Programming. He goes into a little bit more detail about that. So, all right, let's move on to the next. All right, CTEs. This one's kind of a fun topic, actually. If you haven't messed with CTEs, let's go over a quick definition. CTE stands for Common Table, I'm going to get it wrong now that I'm in the spotlight, Common Table Elements. I probably got that wrong. I've been saying it all day long. We'll call it Common Table. A CTE is essentially a temporary view that's attached to a SQL statement. And it's not just Common Table Expression. See, I knew the word was evading me. A temporary view attached to a SQL statement. Now, I didn't say a select statement. You can use CTEs in more than just a SQL statement, but we'll take a look at that a little bit later. This is new in 2005, and there are a couple of really, really cool ways that you can use this, and we'll get onto the super cool way in just a minute. The first thing you need to know about CTEs is that they're good for pulling out some of your processing logic. Say if you had to do some heavy calculations within your select, it wouldn't necessarily be a bad idea to pull those out into a CTE and separate them from your query proper. It makes it easier to read. It segregates your work a little bit so that it's easier to support. And another thing, I've looked around and I've done some experimentation. I can't just stand up and say that CTEs absolutely always have better performance than, say, using a temporary table in the same situation or a table variable in the same situation. But it is another tool in the arsenal, to mix metaphors for a second, to find the query with the best performance. So as you're going through and you're solving problems, you can say, well, which is going to work better? Is it going to work better this way, or if I put it in CTE? Now, having said all of that, let's actually see what it looks like. CTEs begin with the keyword with, and then it's very much like the definition for a view. You've got a name, you give it a name, and you may not know that you can do this for views, but give it a column list. Now, this is optional in views. It's actually optional here too, but more on that in a minute. So with CTE name, list of columns that we're going to send back, and here's the actual definition. Here's the data that we want within our CTE, within our little temporary view. In this case, we're doing something just a little bit funky. We're selecting the top 50 employees ordered by hire date. There's nothing wrong with that. And then in our query proper, we reference our CTE by name, just like it's a table or a view. You can select from it, join to it, whatever. Where last name is less than N. Now, if you go through this code, which I'll make available on my blog later, and try to make sense of what on earth someone would use some of these queries for, yeah, you really shouldn't. You'll hurt your head. Long ago, I gave up trying to create queries that represent things in the real world. One, because it's too hard, and two, because I have so often found myself writing queries that an outsider would just go, what on earth are you writing that for? Who would need that data? Well, that's the business. Somebody asks you for some weird piece of data, so you write a query that looks like this. But anyway, back to CTEs. So yeah, we can reference this set multiple times within our statement proper, within our select proper, and it's really useful. Let's move on, shall we? All right. So we said before that CTEs can be used all over the place, and selects clearly, as we just showed. Did I actually run that? No, I didn't. I skipped right on down without proving to you that it works. So we'll hop back up, and I'll say, here, let's use AdventureWorks, shall we? And let's run it. Ta-da! There you go. It really, really works. And we have 38 people by early hire date with last names that start, there we go, with a letter earlier than N. I don't know. Well, I do write these queries, but it's not my fault. So CTEs can be used all over the place. We saw it work in select now. I've proven it to you. They also work for insert, update, delete, merge within stored procedures and triggers and functions, and in create view statements, which I think is kind of cool. So again, let's kind of prove that that works. Let's create a view using the exact same query. I've taken out the ordered by just because I'd have to do like a select top 100% in the view. Views don't care about order bys. And there you go. We select from our view. I'll edge down a little bit and slow down a little bit so you can see what I'm talking about. There you go. That can be extremely useful. Again, the exact same reasons why you'd want to use a CTE in a select. Same reason. Side note, real quick. Remember, please, this is a public service announcement, that it does matter how performant your views are. If you have views that you haven't really paid attention to performance, you are going to see a hit. But let's talk about real quick one of the gotchas dealing with CTEs. This is one of the very few T-SQL statements that has a semicolon requirement. If you have more than one statement in a batch, and there's a CTE that's not the first statement in the batch, then you're going to have to include a semicolon, or else you're going to get an error. While we should all train ourselves, because I suspect we're heading in the direction of using more and more semicolons in all of our T-SQL statements in the future. I have no insider knowledge on that. It's just a suspicion. So we should probably all train ourselves to use semicolons at the end of statements. Good for you if you already do it. And if you don't, I know a few people, myself included, that just start every CTE with a semicolon. So, all right, moving right along, Fozzie. Now, again, mega cool, you can also define multiple CTEs in a single statement. And all you need to do is use the format with CTE name, columns, and then the definition, comma, CTE name, so forth. It's going to bother me if I don't fix this, excuse me. There we go, with CTE name. So let's take a look at an example of that. All right, we've got our first CTE up here. It's our top 50 again, our top 50 employees this time by employee ID. And then we've got comma, our second CTE. There's the name. There's the list. And you notice it's not like a union. These can be completely separate. You're just defining two different data sets to make available within your select statement. And this time we're getting instead of the same thing, but it's the bottom 50, so we're ordering by employee ID descending. And I'll prove to you that it works. It works beautifully, and everyone's happy. I just think that's cool, don't you? And we'll hop down again, and then I'll show you the really, really mega cool, everybody loves it reason to use CTEs, and that is recursion. Now, you can do recursion. You can get, with old school SQL, I'll say, you can get a nice hierarchical list of employees or product parts or whatnot with old school SQL. But this is a place where I can say that CTEs are much more performant. And we'll go ahead and run it first and then actually go over the syntax. It's very, very quick, very good stuff. So again, starting off with our CTE name, our column list, and here we've got our two statements. We've got what's called the anchor statement, and in this case, what we're looking at is a hierarchy of employees. So we're going to go ahead and start with the top dog, the CEO of the company. He's got no manager ID, right? So this one guy, I'm going to run that. All right, our CEO. Now, the way you make it recursive is union all within your CTE to a second select where you join to the CTE itself. And this is our classic, employee's manager ID equals the direct report's employee ID. So that's how you're getting your looping. It's not technically a loop, but you know what I mean. Now, a quick note here on recursion. The server-wide default on recursion is 100 on the levels of recursion. So it'll go through and go down 100 levels deep before it fails out and says, that's too much. I'm afraid of going into an infinite loop. You can change that with a max recursion hint if you'd like, and that's in select, insert, update, and delete. And let's go ahead. We already ran this, right? No, we need to run the whole thing to prove that it works, right? All we've done here is select the manager ID, employee ID, and so forth from our CTE, and then we ordered them because we like orders. There you go. There's our CEO, and here's all the guys under him, and so forth. And I'm going to slow down just a tiny bit because I was told there's a lag on this. So let's go ahead and make this an infinite loop just to test that max recursion, thing. We've got we started with the anchor being manager ID up at the top. Manager ID is null. Well, what if we change that so that our CEO actually has a manager ID? Now we've created an infinite recursive loop. It's just going to run forever. Or it would without that max recursion limit, which should come up any moment. Oh, that's right. To make it actually recursive, I need to go not where manager ID is null because that no longer exists, we gave that guy a manager ID. Where employee ID is 109, that's the employee